Welcome to this introductory series of training videos for SolidCAM. This video's topic is the pocket operation. So the pocket operation inside SolidCAM essentially is for doing cavities with bosses, pretty much just a very classical toolpath from SolidCAM. So let's take a look at how SolidCAM does it. So to get to the pocketing operation, you can go to your SolidCAM Operations tab, 2.5D, you find Pocket. You can go to the SolidCAM 2.5D section of the tabs, and you can go to Pocket. Or, like I always show, you could just right-click on either Setup, or in this case, since I already have a face milling operation, I'll right-click on that, and I can add the toolpath immediately after by going to Add Milling Operation, Pocket. The operation manager from SolidCAM pretty much is the same for all our toolpaths, so the workflow will be the same. We're going to choose a geometry, then a tool, establish our levels, and then define some of the particular parameters of the operation. We'll start by choosing the geometry. So the geometry for a pocketing operation is chain geometry, and the chain geometry comes right from the geometry that you brought in as your CAM part file when you first created the CAM part file. And we don't really have to sketch anything, although you could use sketches, but I'm just going to grab right from the solid model itself. So I'm actually looking to do, let's say, this entire inside area. I'll grab that chain there, and that is the edge of the solid. You can see it's highlighted in yellow. At least on my system, it's highlighted in yellow. In your system, it might have a different color scheme. And you can see there's some blue highlights there as well. Now, the blue indicates that there's a possible selection at that vertex. If we really zoom in there, you can see that there's an edge there and there's an edge there. And that's because when you do chain selection, you actually have the ability to go up and down in Z as well, because all you're really doing is projecting this to the tool plane. If we take a look on the left side here, I have a box that says Show Chain on Working Plane. So if I wanted to, I could go down and then across on these edges here. If I wanted to include, let's say, this edge over here. So you have the ability to chain on all the edges, and all it does is just project onto the tool plane. This is very helpful if you're doing a pocket that happens to be in a tapered face. So you don't necessarily have to worry about the tapered nature of the edges. It just gets projected, and it's a prismatic view of that pocket regardless. Other thing to notice is the red arrows. The red arrows indicate the cutting direction. As a pocketing operation, I'm only doing the inside of the chain, but I can do the inside of the chain as a climb milling or conventional cut. So the red arrow just indicates the cut direction, the selection of the chain itself. When you go to choose an edge, if I just step out back here without nothing, if I choose the edge of the line more on this side, then the cutting direction goes in the opposite direction. So I chose it on this side to get that climb milling direction. So by doing it this way, I've actually not done what I intended. I wanted to use this line, but not in that cutting direction. I can just come over here and I can just say reverse. Now the cutting direction is in the right direction. If I look at these double arrows, basically that's indicating the next selection. I can zoom in here. I can grab that guy there. I can continue to grab the geometry if I like, but that can get a little tedious, especially when there's some little edges there. I don't want to have to keep zooming in every time just to grab the edges. So in the chain list, I actually have the ability to use some of these options here. So let's take a look at those options. First one I want to show is the next button, or the add selected element. So right now it's thinking to go in that direction, indicated by the red arrows, and that blue highlight indicates the possible next element that I can select, that curve. If I just click next, I can do a next all the way across this thing. As long as the arrow is going the direction I want it to go, I can keep clicking on next. But let's say, for instance, I don't want to go that direction. I want to go down and maybe across. Well, without having to zoom in and click on that line, I can just do a change of direction here. So see how the red arrow changes direction. So at that vertex, I have two possible next elements, the curve or the vertical line. I can click on either one of these, and I can select that. And you can see that at that vertex, it can go either that direction or that direction. So again, I can click between those as well. But let's say I didn't actually want to go down that vertical line. I actually wanted to continue on the top face of the part. Well, the blue curved arrow is my undo. So I can just step back as much as I want to step back. Let's go back all the way to the original line. Now let's say rather than clicking on next every single time, I know that this entire chain is all in the same Z plane. There's a constant Z relationship between all those elements. Well, constant Z relationship means I can click on constant Z. and it finds the rest of the chain for me in that same plane. Let's say I don't want that. I can't do that. Maybe they're not all on the same z-plane. In a single click, I can get it to do all that for me, but let's say they're not in the same z-plane. I'll uncheck that box. But they are all tangents. All those curves are all tangential to each other. All those lines are tangential to the curves. That means there's a tangential relationship. I can just propagate along that tangency. Click on that one edge, and again, it goes all the way around. So if the chain of the pocket, again, was on a tapered face, there's no constant z relationship, but the chain is still tangential to itself. It's a nice curved part. I can still use the tangent propagation there as well. Now I can get it to do that with a single click every time I have these boxes checked. Let's say I'm not looking to do the entire chain. I want to just maybe go from this first line and only stop at maybe this line here. Or maybe wanting to change direction as I get to that vertex. Well, that's what the up to entity is for. I can click on up to entity and then turn on constant z. And now what it's going to do is it's going to go find a constant z relationship between what I just selected and what I'm about to select. So if I click on this line here, in the cutting direction, it finds that relationship with that line there. So it just stops there, waits for me to click on the last entity. So from there, again, I could probably click over here, finds the constant z relationship, but still stops short of completing that line. If I take these off, then you see that it brings up those next element lines again. I can just finish this off by clicking on next. It's okay to accept because it closes the chain. Other options in here include things like point to point. So let's say I had an open edge to my pocket and I wanted to close that gap. I don't really have a wall here, or I'm looking to maybe do a pocket that I want to jump over some surfaces that I don't necessarily have any lines that let me do that. Point to point is literally just choosing the points myself. So rather than choosing the edges, I choose a vertex, and then I can click on another vertex, and then it creates a line. And that lets me do some stuff where maybe I want to pass this completely. I can go and click on another vertex over here, and it creates that imaginary line for me. So that, I call it an imaginary line because it's not an edge from the solid, but that now becomes a piece of chain geometry. I can use that if I were looking to do some sort of pocket that is not represented by the solid or a sketch line. Okay, so let's select that geometry. Now this is the pocket operation. It's in the 2.5D section, but we still have some 3D functionality here. It's not going to recognize it for me, but I can get some gouge checking going on because I have that target defined. And if I had a fixture defined, I can get that fixture collision protection going as well. So what this will allow me to do is recognize, in the case of this particular pocket I chose here, that there's actually some islands here, or at least there's a tab here and an island here. And I don't want to gouge those when I do the pocket. So with this turned on, we're actually going to see a couple things. First, let me turn it off. I'm going to generate this without that, and we can see exactly what's going to happen. We'll come back to that. Let's go to Tool and select our tool. So we'll click on a tool. We'll select the tool from our local library here, the one that's inside this CAM part file. How to create milling tools was covered in a previous video, so I'll refer you to that previous video in this introductory series. But for pocketing, we can use any type of tool that would make sense in this window here. So you'll notice that there's no drills or taps because obviously we're not going to use that in a pocketing toolpath. But we do have everything else in here that you might use for a pocketing. In this case, I'm just going to use a flat end mill. We're going to use this 1-inch flat end mill. As soon as I select the tool, I can go to the Data tab, plug in my feeds and speeds. Under Levels, I can get it to recognize from my stock and target if I like. So I can say by top of target, by top of stock. In this case, I've already faced the part, so I'll go right to the top of the target because it's been faced there. But if I didn't do that, I can actually start at the top of the stock, or I can use my user define option. I'll just highlight this and click on the geometry itself. I can still get that associativity. I have full control over that. But in this case, I'm going to give it kind of a level of automation here. I'm just going to say go to the top of the stock, or top of the target here, because I've already machined off that face there. In terms of the pocket depth, this is an incremental amount from that level. So right now, if I plug in a number here, I would plug in the depth of the pocket, or I can just get it to read some stuff for me. So I can go from the top of the target always, and then give it a delta of a certain amount, so that this makes it very incremental. This makes it almost like a variable that you can use for things like templates and such. I can go to the bottom of the target in the case of a through hole, if I really wanted to, or I can go to the bottom of the stock again. If this was a through hole, I wanted to go all the way to the bottom. I'm going to get this to be user defined. That way I can control exactly how deep it goes into the part. I'm going to click on this bottom face here, even knowing that I chose geometry at the top. If I go to the bottom here, I'm going to gouge these guys, but I'm intentionally doing that to show that gouge protection later on. This is a pocketing toolpath. We're going to be traveling through, in this case, it looks like 1 1/8 amount of material, so we're going to need to step down. If I leave this at 0, or a number larger than the pocket depth, then I'll do this in 1 depth of cut. And if my tool can handle that, then I'll do that. But I think I should take this in some steps. So I'm going to put this at a 1/2 inch. I'm using a 1-inch tool. I'll put it in a 1/2 inch step down. But 1.125 divided by 0.5 is not an equal number. I'm going to get the first 2 passes of a 1/2 inch, and then the final pass of that 1/8 of an inch. So rather than waste that last pass just doing a little bit of material, I can equalize the pass. If you look at that icon there, you can see that it actually is equalizing the path of the tool. So in this case now, it'll take that value, divide by this value, make that a maximum. So it'll reduce the step down, but it'll keep the same number of steps. In this case, I'll still get those 3 steps, but it'll be 1.125 divided by 0.5 number of steps. Let's go to technology. So in every SolidCAM toolpath, the technology section is where you'll see the specifics of that particular toolpath. In this case, we're doing pocketing. So this technology window controls the generic parameters of a pocketing toolpath. We have our overlap, which in this case is the inverse of a step over. So right now I have it set to 50% of the tool diameter. That means I'm stepping over by 50% of the tool. If I set that to 30% overlap, I'm actually stepping over by 70% of the tool diameter. I could do percentages, or I could just put a value here. So if I wanted to do a particular overlap value, I can plug that in. If I've got multiple pockets and I don't want to do the first pocket and then jump to the second pocket, I want to do equal sides, I can just do complete step over, and you can see from the numbers there, it'll do 1 pass, 1 depth of cut on 1 pocket, jump over to the other pocket, and it'll keep jumping back and forth until it gets down to the bottom of both pockets. Pocketing operation could be used for both roughing and finishing. So in our offset section, if I wanted to make sure I leave material on the walls for finishing, I could put 10 thou on the walls. If I had any islands in my geometry, in this case, if I had a chain within the chain representing an island, I can put material on that face on those walls as well. And then the floor, I might want to leave some material behind for floor, so I'll just put in 10 thou there. So that leaves 10 thou after the roughing passes. But if I want to use the same tool to finish the part, I can finish the wall and the floor by checking those boxes there. And then by checking those boxes, it opens up some of the finishing operations down here as well. So I can tell it to do number of passes on the wall, so that I can do a spring pass if I want to. I can define them by the geometry, as you see there, or as an offset. And if you look in that bottom left corner there, it's actually just defining what to do in those corners, depending on what you do there. Depth, you can give it some depth control there as well. Wall offset, floor offset only, and compensation on the roughing passes and the finishing passes. So you get full control over every aspect of the pocketing operation in this one window. But how the tool moves across that chain geometry, you control over here. So under technology, we have 4 types of technologies. These are basically the trajectories across the geometry that you chose. So right now we're using contour. Contour is what you see in the bottom left corner there. It's basically that classic pocketing toolpath, the classic racetrack style. As soon as you choose anything in the technology menu, the second tab shows us the parameters. So do we want to do a contour from the inside going outwards? When you say inside going outwards, it finds the mathematical center of that chain geometry, and then that's the start point. If I had an open pocket, or at least an open edge, I could do outside going in. If we are doing a geometry that has some 90-degree turns in there, some sharp corners, I can tell it what to do in terms of a corner. So instead of doing a 90-degree turn like you see in the icon there, I can click on fillet. It adds a little bit of fillet in that corner, fillet under your control. I can do a loop, which basically means that in that 90-degree turn, rather than leaving some material right there at that corner, I can loop out, loop back in to eliminate that material. And sharp, basically the same idea, except this time it's just going to jut out, jut back in, and continue. I mentioned before that the cutting direction is represented by that red arrow. That really just defines the chain to make sure that you're selecting in the same direction. Here, you actually can tell it climb or conventional cut, depending on what your tool is able to do. In contour, we're doing a radial or a lateral step over, so you can tell it how to do that step over. So from one pass to another, you can do linear, or you can do smooth. Really, it's just that arc or linear move. Toolpath optimization. What you'll see is when you generate the toolpath, if the toolpath has a little bit of some passes that are crossing or whatnot, you want to optimize that, you can just click on toolpath optimization. You'll see that within the toolpath, it changes the movement of the tool. If you wanted to make sure that you exit the material rather than trying to go around it, you have the ability to do that there. You'll add a couple of retracts. And if there's any islands, you can connect the islands, meaning that when you see the toolpath, if there's any islands in your geometry, you have the ability to smooth out the toolpath by connecting the islands. Go to technology again. We'll set this to contour, from contour to hatch. Now, in this case, it won't really apply to ours too much because we're on the inside of a cavity, but if you had the pocket that was, it had a longer direction and a shorter direction, this might apply a little more specifically. What you're doing with hatch is a zigzag style cut. So you're going along a certain direction, the direction you define here. So 0 degrees, user-defined angle, is essentially the x direction. So if we take a look at my part, the x direction is in this direction. So I would be zigzagging across my part in that direction. If I wanted to go in the other direction, I can set that to 90 degrees. If I don't know what angle to put the hatch at, let's say I have an askew part or an irregular shaped pocket I'm trying to machine, and I'm not sure what angle to put it at, I can just click on optimal angle, and it'll determine the longest passes across that pocket. This is a functionality that's very similar to what you would see in the face milling operation. Keep cutting direction. Well, as it goes across the part, I can either get it to continue in that same direction, or as it steps down, I can get it to switch the cutting direction, as you see in those arrows in the bottom left corner. The cutting direction, if I'm doing zigzag, I can actually get it to either reposition and then go in the same direction, giving it a nice finish if I'm doing finishing, or I can just get it to do a zigzag pattern, which it'll just serpentine or zigzag across the part. This being hatch, we might actually, again, have a 90-degree turn somewhere, so we have the ability to do corners here as well. We can either add a fillet or just do the 90-degree turn. And again, we have the ability to exit the material if we want to. Now, hatch inside of a cavity might not make the most sense because we're definitely going to leave some material along the walls where we change direction. So to account for that, we actually have hatch plus finish. Hatch plus finish has the same sort of parameters here. It's just that if you look at the toolpath itself, it not only does the zigzag, but it has that perimeter pass as well. So with each step of cut, it'll do one pass around the outside just to eliminate any of those cusps or those burrs or anything like that to allow you to do a complete internal pocket. And then lastly is plunging pattern. Plunging pattern is the idea that you might have a pocket or a cavity that's very deep, and rather than just milling it out with a simple pocketing, you might want to do a series of drilling operations. So this will generate a set of drilling operations that you can use to drill out the cavity itself. And the drilling parameters we'll cover in the drilling operation coming in this introductory series. Lastly is your link. Let me just switch this back to contour, and we'll take a look at the link parameters here. Now in link, this is where you can control your lead in and your lead outs and your ramping. So for a pocket, because we're doing a contour style, it's going to start from the mathematical center of the geometry and work its way outwards. So there really is no need for a lead in. But if we wanted to do a particular type of ramp, we have the ability to ramp in just vertically in the Z direction, and you choose the point that you like to ramp in. Angle allows me to do a little bit of a kind of an angular way in. Again, you choose the point and then the angles that you like to zigzag in. Helical, you choose the center of the helix, and then you define the helical entry, the angle and the ramp. And if it's a non-center cutting, the step down as well for that helix. Or linear, same sort of thing. You give it a start point, and then you tell it what angle you'd like to approach from. To lead off the wall, you have the ability to do a lead out. So again, very similar to what you see in the other toolpaths in this introductory series. So let's generate that toolpath, and we'll see what we've got here. So we take a look at it from a point of view of the tool. We do our entry, we do our first pass, lateral step over, next pass, and as we go out, you can see that it's starting to get more and more of the shape of the chain geometry that I chose. The problem is, if you see down here, we're actually gouging that tab there. It's because I chose top contour as my chain geometry, and I told it a Z depth. So it's not really looking at the target at this point. You can see the step downs and all that, but as it goes along, it's going to mill this island, and it's going to mill those tabs on the side. So what we want to do here is dummy proof it by going back to the geometry and turning on that 3D model protection. So we're going to make sure that we 3D model protect. Basically, I'm going to leave 0 on there, but I can put whatever amount of material I want there or any offset I want to put there to protect the target. So with that turned on, I'll just do a save and calculate. You can see now that it trims the toolpath to the target itself. So even though we're starting way above this tab, we're only defining it as a 2.5D toolpath. So we can only control it as per the whole target, but with that one chain. So what that actually means is we're going to actually go around that tab in this toolpath. We're going around that island, and then the only thing we could do in the middle there is just work inside of that island. But you can see that it's trimming all the way around there. That will leave a donut shape around here. There's a material there that's represented by that island. So I probably don't want to do it exactly like that. If I'm planning on doing this material, I probably just want to reduce the levels so that I can do it to this island. I can machine out an entire chain like so. So I still get what I had before, it's just I'm not going as deep. So let's do a save and copy, basically saving all these parameters. Same tool. I'm actually going to change the levels down to there. And we'll do cut only rest material. So from the same levels, we should be able to just do a save and calculate. With the tangent protection turned on, and it recognized that from my previous toolpath, same tool, same chain, but with the target protection turned on and going to the lower level, it didn't have to do all the steps. The levels are still the same, but it recognized that in this Z level, it only had to go from the top of that tab down to that face. So I was able to continue the toolpath. And I mentioned before the optimization. Let's just go to contour, toolpath optimization, and we'll clean that toolpath a little bit over there. So we're not getting any kind of cross-linking. We'll get it to do a little bit of a cleaner toolpath. So that is the rest in the Z direction. But let's say down here, if we take a look at our updated stock, I'll just check the box here and move the follower down to that toolpath there. We should see that the 1-inch tool obviously didn't do those corners. So I need to bring in a smaller diameter tool to do those corners. So what I'll do again, let me just turn off the updated stock. I'm going to open up this last toolpath here. And we'll do another save and copy. So again, saving all the parameters. This time I'm going to use a different chain geometry. Now I could use the same geometry, I could use the same parameters, but I'm going to assume that I'm starting from scratch. So let's say we do a constant Z all around there. I'll leave the 3D model protection turned on because I did not include that island. So I wanted to control that just in case. I'll turn this guy off. The tools, let's switch to the smaller diameter tool. We're going to switch to the 1/2 inch. So obviously a smaller diameter tool. If I generate the toolpath as is now, I'll actually change this to start here and here. So I'm changing my level. So I did a save and copy, but I am effectively changing a lot of the stuff here. If I leave this as is, it will generate the entire toolpath. It'll do a contour with all the parameters I just plugged in. and it'll actually do all of that all over again. But that's not what I'm looking for. I'm looking for it to recognize that the 1 inch already did some work, and I want it to clean up what the previous tool did not. So effectively those corners. What I can do is turn on rest material. So by just changing this to rest material, it opens up this new tab where it's asking me what I want to do. I want to do the separate areas, or do I want to do the around profile? I want to just do the separate areas. I just want to do the areas that the previous tool left behind. I'm going to leave no material on the walls there. I'll leave a little bit of a floor offset, and I'm just going to basically tell it what I want to do here. So the previous tool diameter was 1 inch. Previous wall offset was 10 thou, and then I didn't have an overlap. Just by changing it like this, you can see that it's actually going to machine just what was left behind. And the overlap, we actually go in here, allows me to kind of feather it out a little bit as well. So we generate it without that first, and then we'll see what we can do with the overlap. So it recognized from the chain geometry that I just need to do just a little bit of an entry in there to do those corners. And you can see that it does all the corners. It recognized everything that the previous tool could not have done. Even with the tangent propagation or the target gouge protection turned on, it recognized the island, couldn't do the island, but it recognized that there's some corners there as well. So now that does a rest operation. That's cleaning that up for me. And it starts and stops just around where the material is. But I probably do want to kind of add a little bit of feathering in, a little bit of a lead in there. So let's just do an overlap of 50 thou. So it actually will start 50 thou in the start and end, and actually works its way in a little bit as well. So we're not actually starting right on the material. So that's a good way to get this part to be fully roughed out. You can just do a save and copy, step down the tool, and it gives you the ability to further work on the part without having to start over again or chain different sketches or anything like that to represent the remaining material. You can tell it what the previous tool did and what we want to do with the step down of the tool. Any questions on this or anything else from SolidCAM, just give us a call at 1-866-975-1115, extension 2. And stay tuned for the rest of the videos in this introductory series. Thanks for watching.